Let me introduce myself. My name is Peter DeSantis, and I run our AWS Global Infrastructure and Customer Support teams. I've been at Amazon for over 21 years, and in that time, I originally worked on the Amazon retail business, and then in 2006, I moved to AWS, and I've had a number of different roles since the early days of AWS. And when people find out that I've been at Amazon for so long, they often ask me what keeps me there. And the answer to this is simple for me. First, I've had the opportunity to work with a number of brilliant, interesting, and passionate people. And second, I've had the opportunity to build. I am a passionate builder, and the ability to build new things and put them in customers' hands is what brings me satisfaction in my job. Now, I know this room is probably full of passionate builders, and hopefully you're here to find out how you can build cool and new things for your customers. Now, one of the things about building is that having the right tool is critical. It makes things easier, faster, more cost-effective. I'm a builder. I'm a builder at work, and I'm a builder at home. These are actually my tool chests, not servers. And if you notice, if you look really closely, I actually go so far as to put barcodes on some of the drawers in my tools. I've built an app to help me find the tool that I'm looking for, because nothing is more frustrating than not being able to find the right tool when you're trying to build something. The same is true when you're trying to build applications for your business and your end customers. Without the right tool, you end up making compromises. You compromise speed, you compromise cost, you compromise functionality. Having it all really matters. And this morning, I'm excited to spend some time with you understanding the breadth and depth of AWS, because the reality is there is nobody close to having all the functionality of AWS, and that matters. AWS has a robust, diverse, and fully featured platform with over 165 different services. We have core infrastructure building blocks like compute and storage. We also have relational and non-relational databases, analytics, machine learning, IoT, just to name a few. But having a broad range of services is not enough. It's only one part of the equation. You really need to look at the depth and functionality of each and every one of these areas to understand the capabilities of the platform. A lot of providers will be able to check some of these boxes. Some of them maybe can check all of the boxes. But if you look a little deeper, a little closer, you'll see that AWS has by far the most functionality. And it doesn't take long to see this difference when you're trying to build an application. Let me give you a few examples. I'm going to start with the AWS Global Infrastructure. Now, when you look at this map, it's easy to see the breadth of AWS. This map shows the 20 geographic AWS regions, as well as the 5 that we've announced coming soon, including regions in Hong Kong, Bahrain, Italy, Cape Town, and as Nick mentioned, just last week, we announced our intention to launch a region in Jakarta, Indonesia. But even something as seemingly straightforward as global infrastructure deserves a closer look. Our approach to building infrastructure is different than our competitors in a fundamental way. Each of these regions is actually composed of multiple availability zones. An availability zone is a fully isolated partition of our infrastructure. And by building each of our regions with multiple availability zones, we give our customers the ability to run high availability apps close to their end users while keeping their data resident in the region they choose. This is a completely unique characteristic of the AWS platform. Let's look at a few others. Let's look at databases. It's becoming more and more important to be able to pick exactly the right purpose-built database for your job at hand. Recognizing this, AWS offers 14 database services, double what any other cloud provider offers. And sometimes you need to change your database because your apps change or your requirements change. And to do this, we offer the AWS Database Migration Service to easily migrate between database types. This is the only service out there that makes it easy for you to migrate between SQL and non-SQL or back. Choice matters with storage as well. Sure, you can check the obvious box. You have block storage, you have object storage, and you have file storage. But there's really much more. With block storage, you have lots of volume options. You need different performance options and different reliability options. You need the ability to manage snapshots across all these different volume types. You need to be able to adjust performance and modify volume type on the fly. And if you look at object storage, you want object storage that gives you the best security, the best availability, and the best scalability. But you also want the ability to do object-level control at any scale. And you want the most integrations with other services. And that brings us to file systems. AWS has several file system options, and this is very important because file systems, like databases, need to be tailored to your application. So whether you need a high-scale cloud-native file system, or a simple-to-use Windows file system, or a high-performance scale-out file system, AWS has those offerings, and more. And of course, you need to move your data into and out of these services. And for that, we have 11 unique ways to get your data into AWS or out of AWS, more than you'll find on any other platform. And nothing is more important to our customers than security. And breadth and depth is particularly important here. AWS offers more than 200 different security features and compliance features, by far the most of any cloud provider. If we look at something as important as encryption, all AWS services that store customer data have encryption enabled. That means we have encryption on 116 different services, which is 3 times more than any other provider. And sometimes you need more control than just standard encryption. Sometimes you want to control the keys. And with Amazon KMS or Key Management Service, you can control the keys to 54 AWS services. That's 4 times as many as any other provider. Now, I know I just moved very quickly over a number of different topics. And really, you could double-click into any of the areas and any of the service areas and find the same level of rich functionality and breadth and depth. But today I'm going to spend some time talking to you about how this breadth and depth of these capabilities is the how for getting what you want done. We'll also hear from a couple customers this morning, talking about how they're using this breadth and depth to build their own applications. And maybe at the end, we'll have a little bit of fun. OK. Almost always when we talk to companies, the reason they choose to move to the cloud is the agility and the speed that it enables. And that's why customers of all sizes and all industries are migrating to AWS in a big way. So let's talk about enabling migration. One of the things we've learned in helping the world's largest enterprises migrate their legacy applications to the cloud is that there is no one-size-fits-all solution. If you want to move as fast as possible, you'll need the deepest and broadest set of tools. And one of the first things that customers do when they're looking to migrate is to migrate their data. As I mentioned earlier, we have 11 unique ways to migrate data into or out of AWS, nearly double what you'll find anywhere else. Let's look at a couple. AWS Snowball is a petabyte-scale data transport appliance that is designed to be secure and transfer large amount of data into and out of the cloud. Transferring data with Snowball is simple, fast, more secure, and can be as little as 1/5 of the cost of using a network. And AWS Snowmobile is the first petabyte-scale data migration service. A Snowball is a secure data truck with 100 petabytes of storage that can be dispatched to your data center, connected directly to your backbone, and used to ingest large amounts of data into AWS. AWS Data Sync is a data transfer service that allows you to more quickly copy data into and out of services like S3 and EFS. You can achieve performance that's 10 times better than tools like Robocopy or rsync. An AWS Storage Gateway is a device that helps you easily connect on-premise applications to AWS storage services. Now, one of the fundamental building blocks of any application is the database. And so we have specific tools to help you migrate your databases. AWS Database Migration Service allows you to migrate your data to AWS. And again, it's important to realize that it allows you to migrate your data into and out of AWS. We've done more than 120,000 databases with this service. HonestBee, an online grocer and food delivery service provider, is running its data warehouse on Redshift. And they're using the AWS Database Migration Service to migrate their Postgres RDS to Redshift. HonestBee is now able to move data to their end users with a latency of under 5 minutes. This compares to the 7 hours they were doing previously. And when we think of migrating applications, we're focused on supporting the environments that your company and your applications are familiar with. A great example is Petronas Lubricants International, or PLI, the global lubricants manufacturing arm of Malaysia's national oil company. Petronas has standardized its application processes and consolidated multiple versions of SAP and non-SAP systems, migrating these to SAP for HANA on AWS. This provides PLI with cost benefits as it rolls this migration out to 30 countries and increases the speed of its dev test cycles. It's also shortened the implementation time by 3 months. By modernizing its apps, PLI is further set up to adopt advanced services such as serverless, IoT, and data lakes to serve its business users across the world. You'll also see Windows up there. And you may be surprised to learn how many Windows workloads are on AWS. AWS has run Windows for over a decade. And according to a report by the IDC, there are nearly 2 times as many Windows servers workloads running on AWS as Microsoft. Our experience running Windows has earned our customers' trust. The number of enterprise customers using Windows on AWS has grown by over 400% in the last 3 years. We have hundreds of thousands of customers bringing Windows to AWS, including Autodesk, which has been running Windows on AWS for over 10 years, and Salesforce, which runs over 10,000 Windows instances. Many of you might be asking, well, what about hybrid? While we believe that the majority of workloads will run almost entirely in the cloud in the fullness of time, it's a priority for us to give customers the ability to run AWS as a seamless extension of their existing infrastructure. If you think about it, pretty much any customer who's not all in on AWS today is running a hybrid architecture. And we see our role in hybrid architecture as making it easy for customers to run their on-premise infrastructure right alongside AWS. By working closely with enterprises, AWS has developed the industry's broadest set of hybrid capabilities across storage, networking, security, application deployment, and management. For example, AWS Direct Connect lets you easily and reliably connect your on-premise environments with AWS through a set of network options and services. Or AWS Outposts, which we announced at reInvent last year, which allows you to bring native AWS services and infrastructures to virtually any data center, co-location facility, or location in the world. Outposts allow you to run compute and storage for certain very low latency workloads on your premises, but in a way that seamlessly extends your on-premise or your existing AWS environment. Snowball Edge Compute Optimized is a great way when you need to run a small amount of compute at the edge in either a network disconnected format or somewhere where you need a ruggedized container. And finally, VMware on AWS allows customers to use the same software they've been using on-premise on the AWS platform. We've seen a lot of momentum for VMware Cloud on AWS, and it's why we've worked so closely with VMware to build a deep partnership. With the launch of VMware Cloud on AWS, Customers have the ability to use the same VMware software and tools that they've been using for years on-premise, but run them on AWS. So, we have many, many customers migrating to the platform or operating in a hybrid as they transition to AWS. But what about those that are building entirely new applications? We have a ton of customers that have built and run on AWS since day one, or they're going through digital transformations and inventing new customer experiences. We talked a lot about migrating apps, but when we're building new apps, customers are moving to an architecture called microservices. What do we mean by a monolithic architecture or microservices? Well, with a monolithic architecture, all your processes are tightly coupled in one application. And this is actually how we built things when I joined Amazon. I joined as a software engineer, and if you can believe it, at the time, there were only a couple dozen software engineers at Amazon. And we all worked on one big piece of code that we called Obidos. And depending upon how you used Obidos, it could do almost anything. It ran the retail website, it also ran our customer service centers, and it could run our fulfillment centers. And one of the things that we learned pretty quickly is that monolithic software doesn't scale. As our software teams grew into the hundreds, we were constantly stepping on each other's toes by breaking the software build or simply struggling to make changes to an ever-growing code base. What we learned was monolithic software limits experimentation, and it makes it hard to implement new ideas. It also increases availability problems because a single small problem in your monolithic application can cause impact to lots of other things. It also impacts scaling because with a monolithic application, if you need to scale one part of the application, you need to scale the whole application. Now, with a microservices architecture, an application is built as independent components that run each application process as a separate service. And that's where they become so valuable, because you can iterate on each microservice to deliver just the functionality the customers of those services need. And at Amazon, we discovered that by factoring our software into small services, we could move a lot more quickly, something we were eager to do. So we started building services for everything. And in a few years, we had hundreds of services. We had services for customer information, services for personalization information. All of these little tiny services replaced Obidos, the monolithic software application. This was a pretty innovative idea back then, but it's even more important today. Because microservices are independently run, each service can be updated, deployed, and scaled to meet the demands of that service. So each engineer has both the knowledge and the authority to make local changes. You end up with the ability to make decisions very quickly and move very quickly. And whenever people talk about how we transferred our internal development processes, they want to know if they can do it themselves. And the good news is, you absolutely can. And we've made the tools that we use available to you as well. We've built services to help with each stage of the development process. And we've also got a service called Code Pipeline, which manages all the stages of development. As we look at the move from monolithic software to microservices, let's look at how compute enables this. Compute has been changing quite a bit. When we first launched EC2, compute was basically virtual machines. Today, we still support that model, and we have a large range of instance types. But we've seen the rise of containerized computing and event-based computing. Today, many of our customers find that a combination of all three of these models works best for them. So let's zoom in on instances. AWS has over 190 different types of instances. We've got general purpose instances, but we also have instances optimized for machine learning or HPC or big data workloads. We've also got the most powerful machine learning instances in the P3 and the P3DN instance. We've got a broad range of processors, including Intel, AMD, and our recently announced Graviton processor, which is an ARM-based processor that can be up to 45% lower cost for your scale-out workloads. In the past years, we've also added lots of capabilities, including the ability to run bare metal, the ability to directly attach an SSD, enhanced networking. We've also had the ability to elastically attach resources. For example, elastic graphics, elastic inference, and elastic block storage. Now let's look a little more deeply at containers. Amazon Elastic Container Service is a highly scalable, high-performance container management service that supports Docker containers. And it allows you to easily run applications or manage clusters of EC2 instances. With ECS, you don't actually have to deal with any of the infrastructure, or any of the container orchestration, or any of the virtual machine clusters. This is all managed for you. And because it's designed from the ground up to work with the rest of AWS, it's easy to build containerized applications. And we've taken this one step further with AWS Fargate. AWS Fargate is a compute service for Amazon ECS that completely removes the need to manage EC2 instances at all. With Fargate, you focus only on your application. In fact, you don't deal with any infrastructure. You can launch and scale quickly and easily. You pay only based on what you use, not on the overall size of your cluster. This allows you to spend more time building and more time innovating, which is what you really want to be doing. AWS Fargate runs tens of millions of customer containers every week. And last year, we launched Amazon EKS, a managed service that allows customers to run Kubernetes containers, but without the hassle of having to build and manage and update their Kubernetes masters. EKS is tightly integrated with AWS, and it makes AWS the best place to run Kubernetes. We're not doing this alone. We're contributing back to Kubernetes community and working with our partners to make it easy to run Kubernetes for everyone. EKS is also certified Kubernetes, ensuring compatibility. And any major change that we make to EKS goes upstream before we release it in EKS as a service. Customers are doing amazing things with containers. Singapore-based customer engagement and loyalty SaaS provider Perks analyzes customer marketing campaign data in real time, turning data insights into actionable recommendations. By running on Amazon Aurora and EKS, it's improved app performance, data loads, and shortened marketing campaigns from planning to launch from 12 weeks to under a day, increasing their user engagement to 83%. Finally, let's look at event-based computing, which we pioneered with Lambda. But it's not just Lambda that you need for event-based computing. To build a truly serverless application, you need support for serverless computing from a broad range of services. Lambda integrates with over 47 AWS services, which is several times more than any other cloud provider. You'll notice monitoring and logging up there. You'll notice identity up there. You'll notice communications. It's not just functions. It's not just managed services. It's a complete serverless application platform. And since Lambda lets you run code without provisioning or managing servers, and it integrates with so many AWS services, it's become a central hub for event-based computing. It's this breadth and depth of the AWS platform that allows you to have absolutely zero focus on infrastructure. And that's why it's a fundamental shift. Serverless computing lets you focus on the things that bring value to your customer, not on the infrastructure, not on IT management. And to help you get started building your own containers and serverless applications, we have a broad range of resources. When we first built these tools, we were mostly focused on EC2 instances. But our customers asked us to start supporting containers and Fargate and serverless computing. This is why Code Pipeline supports both Lambda and Fargate. And you can use the same tools regardless of whether you're running on instances, containers, or serverless. And developers are used to working in environments where they can easily replicate what they're doing in the cloud on their desktop. But how do you debug a Lambda-based application locally? AWS Cloud 9 includes a full create, step-through debug, and deploy experience for serverless applications. And we're taking the steps to meet developers where they are today with toolkits for all the most popular IDEs. And even though we're launching these toolkits to help you with serverless. These toolkits also work with instances and containers. Serverless is happening everywhere, and it's happening at scale. A great example of an AWS customer that is both migrating their applications to AWS and re-architecting is the Certis Group, one of the 5 commercial auxiliary police forces authorized to provide armed security to government organizations as well as companies and individuals. They have started their digital transformation journey last year and have chosen AWS. Serverless is a big part of this transformation. And here to tell us more is CK, Group Technology and Operations.
Thank you, Peter. Good morning. I'm pleased to be here and to share the transformation journey of Certis. Certis has always been the leading physical security provider in Singapore and a key player in the Singapore cash ecosystem. We started in 1958 as a subunit of the Singapore Police Force and then became the statutory board Cisco, and hence the term Cisco Guard in 1972. We were privatized in 2005, and technology capabilities and services were progressively added over the years. Today, Certis is a smart user of technology, and we have been awarded 28 technology-related patents. I'm proud to say that Certis has evolved into an advanced integrated security company. Revenue grew from 200 million to 1.2 billion, a 6-fold increase over 13 years. In 8 countries, key markets are Singapore, Australia, and Hong Kong. Globally, we are 34,000 strong and 16,000 in Singapore. Besides physical security, Certis is the recognized global leader in providing aviation security. We have more than 3,000 staff in Changi Airport, and Changi was ranked first for security at ASQ Worldwide for 3 consecutive years. For technology services, Certis provides both security as well as smart building technology, and it is the largest CCTV installer in Singapore. Over the last 3 years, Certis has been undergoing a deep transformation to prepare for the future. We now combine advanced security, integrated services, facilities management, and guest management into a holistic service underpinned by technology. We call this Security Plus. It is powered by smart operations where we integrate technology and operations to deliver multi-site smart operations. We also leverage on a human-centered design thinking approach to develop optimal solutions to complex problems. Security Plus allows companies to rethink their old silos of security, facility management, and guest management, and to reimagine these silo operations into a single seamless service. For example, major transport hubs, government establishments, and shopping malls count on us to deliver excellent customer service and security at the same time. Our approach has seen a 20 to 30% decrease in manpower deployment. This is significant, and most retail malls are now our customer or in the process of engaging Certis. The next phase of our transformation is digitalization. We need to digitalize the core. We want to create a digital twin of our corporate admin as well as our ground operations. Digitalizing them end-to-end will give us better data. Using this data, we'll be able to reimagine our customers' journey and redefine what problems we are helping them to solve. To do this, we need to be agile, fail fast, but learn faster, and be able to scale quickly. We need a good and reliable cloud provider. But which cloud should we use? Like a typical Singaporean in the new neighborhood food center, when you're not sure which food store is the best, you join the one with the longest queue. So we started engaging AWS last year in March, And we like what we saw. It is reliable, 3 availability zones in Singapore, comprehensive, more than 150 services, a full suite of automated security services, and most important, AWS meets our audit requirements. Then, how do we move to AWS? Do we lift and shift, re-platform, or re-architect? After some workshops with AWS and prototyping, we decided to re-architect our existing ground operation apps first. It was a bold move, but we needed to rebuild our legacy app quickly, and we needed Argus quickly. What is Argus? It is our next generation officer support system, part of our effort to create a digital twin to reach out to 12,000 operational staff. It has a dynamic task management engine, facilitates analytics and optimization, and is AI-enabled. Argus allows us to break down security routines into tasks so that we can get a better and deeper operational insight into our officer activities. It allows planners to redesign tasks and to streamline operations, and also allows to leverage on AWS suite of AI services to build AI into Argus. Argus is a cloud-native app based on the Microservices Architecture, completely serverless with ECS, Lambda, SageMaker for AI, GuardDuty for security, SQS and SNS for messaging and queuing. We have implemented Argus in one of our business units, and initial feedback from users were encouraging. We now have better situational awareness for our supervisors. We are now more agile, and we are rolling out new features every 2 weeks. The rollout to the rest of the business unit in Singapore, Australia, and Hong Kong will be done over 2 years. And the benefit of deploying on AWS are up to 30% shorter development time, 70% less operation and support, up to 10 times lower security costs, and highly scalable to hundreds and thousands of sites in our 3 key countries. Transforming an organization is always a difficult task. Hence, I was tasked to form the Group Technology and Operations Division to drive this transformation. The Argus team was our commando team, the spearhead. They lighted the torch and showed the rest of the guys what amazing things we can do on the cloud. But we need to bring the rest along with us, and that was more challenging. So we're doing it in 3 progressive stages. First, migrating to the cloud. We prototyped 2 test loads on AWS last year. We are now about to complete our landing zone design, and in a few weeks' time, we will start to migrate. So by end of this year, up to 60% of our workloads will be migrated to AWS. In year 2, we will focus on efforts to re-platform and re-architect our apps. The biggest challenge has always been people and culture. First, it was winning the key stakeholders over, and this was made easier with the certifications of AWS and the large client base. We also need to educate, retool, and reskill our staff. And we are working closely with AWS to conduct training, and by end of this year, up to 70% of staff will be trained. We also conducted various technology awareness workshops for the entire Certis management staff, which is about 1,000, and specific training for our senior management team. Then there's also moving from the on-premise mindset to a cloud-first mindset, and that was more difficult than expected. So constant engagement with AWS staff and sharing of experience from our Argus development team made the difference. And finally, integrating operations and technology is no easy task. It requires deep integration between our rich ops experience and advanced technology. In addition, we have to re-engineer our business processes and develop creative solutions. To do this, we must partner our customer. We need to co-innovate with them, and we cannot do it alone. Here, the agility of AWS will allow us to experiment, innovate, and learn quickly. In conclusion, by integrating all this together, you will enable Certis to deliver security plus to all our customers. We are excited by the opportunities, and we look forward to working with AWS in propelling Certis ahead. Thank you.
Thank you, CK. We're very excited to see how serverless is a big part of Certis's journey. All right, we talked earlier about how important it is to have the right tool as a builder. Well, it's also important to be free of relationships with abusive tool providers. If you look at Oracle and Microsoft, they're expensive, they have high lock-in, they're proprietary, neither are customer-focused, and sometimes they're downright abusive. Forget the fact that both of them will constantly be auditing you and finding reasons to fine you. But they also make erratic decisions overnight that seem very good for them and less so for you. People are sick of it. And because databases are such a critical part of your application, it's hard to build when you can't be sure if your database provider is going to prioritize their goals over yours. And this is why customers are moving so quickly to open source database engines like MySQL, PostgreSQL, and MariaDB. But many of them want the open engines with the customer-friendly policies and portability, but with the performance of a commercial old guard database. And that's why we built Amazon Aurora. Amazon Aurora is a MySQL and PostgreSQL compatible relational database built for the cloud. It combines the performance and availability of a high-end commercial database with the simplicity and cost-effectiveness of an open source engine. And because it's MySQL and Postgres compatible, you can easily migrate your MySQL or Postgres applications to Aurora with standard import-export tools or using a snapshot restore functionality. And it also means that the code, applications, and tools that you already use and are familiar with can be used with Amazon Aurora with little or no change. It's also several times faster than MySQL or PostgreSQL, so you can easily scale your database deployment up and down as your apps need more and less performance. And it's at least as durable and available as the old guard commercial offerings. It offers greater than 99.99% availability. It has fault-tolerant and self-healing storage. It's continuously backing up your data to Amazon S3, and it transparently recovers from any storage failures without you needing to do anything. You can also back up to within seconds to a previous point in time, which allows you to recover from logical user errors. All this at 1/10 of the cost. Amazon Aurora is still the fastest growing AWS service. And one of the reasons Aurora continues to grow so quickly is the pace of innovation and delivery. We've launched about 35 significant features in the last year alone, and it's part of the reasons that customers are coming to Aurora in droves. Using Amazon Aurora, Dow Jones shortened the load time of market data from 8 hours to 3 hours. The company migrated its market data system from Microsoft SQL Server to Aurora MySQL, and is using AWS Database Migration Service to replicate data nightly. And while relational databases will continue to be a popular choice for many applications, as I talked about earlier, the move to microservices is driving the need for purpose-built databases. And no one has more purpose-built databases than AWS. There are some apps that need to store and retrieve key-value pairs in large volumes with millisecond-level latency. And they want to scale up without needing to worry about the performance and scale limitations of a relational database. For those customers, we have DynamoDB. Other applications need to access their data even faster in microsecond-level latency. And for these, we offer Amazon Elasticache, a managed in-memory store for both Redis and Memcached. And some apps need to store semi-structured data as documents. They require content management or mobile integration. For these, we offer DocumentDB. And then there are applications that need to enable millions of users to query and navigate relationships between highly connected graph data sets. For these, we offer Amazon Neptune. Other applications need to efficiently collect, synthesize, and derive insights from time series data. And for these, we offer Amazon TimeStream. And some applications want a centralized trusted authority to maintain a scalable, complete, and cryptographically verifiable ledger. And for those, we offer Amazon QLDB. Now, we don't have time to get into all of these in detail this morning. Let's talk about a couple. Amazon DynamoDB is a fully managed, high-scale, single-digit millisecond, high-throughput key-value store that was driven by the performance requirements of Amazon.com. Over the last 18 months, we have delivered many of the most asked-for capabilities, with a total of 29 to date. Let's talk about a couple of the most interesting. Global Tables provides fast local read and write performance for massively scaled global applications and replicates your tables automatically to the AWS regions of your choice. Global Tables enables your applications to stay highly available, even in the unlikely event of an issue with an AWS region. Global Tables makes DynamoDB the first fully managed, multi-master, multi-region database. We also delivered on-demand backups and point-in-time recovery. On-demand backups enables customers to create full backups of hundreds of terabytes of customer data instantly, with no performance penalty to your application. And point-in-time recovery allows customers to do per-second granularity restores to any single second since the point-in-time recovery was enabled. And last year at reInvent, we also launched DynamoDB read-write capacity on demand. On-demand capacity requires no capacity planning on your part. You don't need to do anything. You simply create your table, select on demand, and DynamoDB manages the capacity for you. If you need to scale up, it scales up. If you can scale down, it scales down. And because you're only paying for what you use, your costs are proportional to your usage. Today, DynamoDB scales to support some of the world's largest applications. Consider Duolingo, who uses AWS to run online language learning platforms that store over 31 billion items and include 6 billion exercises. The company reaches more than 18 million users monthly with its free online language learning sites. Duolingo relies heavily on Amazon DynamoDB for a high-scale database, along with other AWS services, including Amazon EC2 for compute, Amazon Elasticache for performance optimization, Amazon S3 for image operations, and Amazon RDS for permanent data storage. Or consider Amazon.com. Amazon's internal workflow processing engine, known as HERD, powers the business logic that allows us to deliver packages all across the world. The Amazon HERD team moved its system from Oracle to Amazon DynamoDB and lowered their workflow execution overhead by 90%. They decommissioned hundreds of Oracle hosts, and they reduced the time they need to scale up for high-demand moments. Earlier, I mentioned Amazon QLDB Ledger Database, and it's worth taking 1 minute to talk about blockchain and how we think about it at AWS. A lot of other companies have been talking about talking about blockchain as the next big thing. It's complicated. Nearly nobody can implement it for themselves without large professional services teams. But that's not what we're about. We want to build products that allow our customers to build without professional services. So we spent a good chunk of last year really trying to understand what customers are asking for when they ask for blockchain. And we found that there's really 2 groups of customers. The first group is really asking for a ledger, which is owned by a single trusted authority, but where the ledger serves as a transparent, immutable, and cryptographically verifiable ledger of everything that happens. And there's a second group of customers that wants to execute contracts and share data with one another without relying on a central authority. For the first group, we built Amazon QLDB, a fully managed ledger database that provides a transparent, immutable, cryptographically verifiable transaction log owned by a central trusted authority. QLDB is built on tried and tested technologies that we use internally at AWS and Amazon.com. It's immutable. QLDB uses an append-only journal to maintain a sequenced and permanent record of each change. These changes cannot be deleted or modified. It's cryptographically verifiable. QLDB provides the APIs to allow you to verify the integrity of the data to ensure that there have been no unintended changes. And it's transparent. Customers have full visibility into the entire data lineage. Customers can look back and easily understand how any item of data has changed over time. For the second group of customers that need to transact without a centralized authority, blockchain is the right solution. And so we built Amazon Managed Blockchain. Amazon Managed Blockchain is a fully managed blockchain service supporting all open source blockchain frameworks. Instead of manually provisioning hardware and managing software configurations, new settings, managing new members, et cetera, you simply set up and start using open source blockchain with a click of a button. You pick the blockchain open source framework of your choice, and it manages the rest. Singapore Exchange sees blockchain technology as a way to bring innovation to its distributed financial marketplace. It's developed delivery versus payment capabilities for the settlement of tokenized assets across different blockchain platforms. It is now working with AWS to move its existing investments in Hyperledger Fabric to Amazon Managed Blockchain to eliminate the heavy lifting that typically goes into managing these blockchain packages and focus on their desire to add value for their end users. And when you look at this depth and breadth of purpose-built databases, there's never been a better time to be a developer or a builder. This really is the moment for database freedom. All right, we've talked about migrating data earlier, but what are customers building with all this data? There is so much more you can do with your data in the cloud than was ever possible on-premise. And customers want to be able to run analytics on all of that data. Again, AWS provides the broadest and deepest portfolio of analytics services. Each service is purpose-built for a specific use case, such as interactive analysis, big data processing, data warehousing, real-time analytics, or visualization. Let's look at a few right now. Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective to analyze all your data. Redshift delivers 10 times faster performance than any other data warehouse by using machine learning, massively parallel query execution, and columnar storage on fast cloud storage. You can set up and deploy a new database in minutes, and you can run queries across petabytes of data. And if you want real-time processing of streaming data, you can use Amazon Kinesis, which has become a key service for IoT applications. Kinesis makes it easy to collect and analyze real-time streaming data, so you can get timely insights and react instantly to new information. Today, we have a family of Kinesis services: Kinesis video streams, Kinesis data streams, data firehose, and data analytics. So, with AWS's broad and deep portfolio of analytics services, customers are getting more out of their data than ever before. And companies are starting to really see the value in bringing all that data, which has been stored in different silos, together into what is called a data lake. Today, customers are running more than 10,000 data lakes on AWS. S3 is the #1 choice for data lakes, and there are a few key reasons why. First, S3 offers the best durability, the best availability, and the best scalability. Only S3 replicates your data to 3 availability zones inside of a single region. S3 has the best security, compliance, and audit capabilities. S3 offers object-level controls at any scale. You can do object tagging, tiering by prefix or tag. You can apply lifecycle policies to tier groups or objects, and you can do cross-region replication. S3 gives you business insight into your data. For example, storage class analysis analyzes your storage request patterns and provides recommendations for setting tiering to lower cost storage. And AWS offers many ways to bring data into S3, which we discussed earlier. And once the data is there, you can use Amazon Redshift Spectrum to connect directly to your S3 data lake and analyze exabytes of data without loading or doing ETL on that data. But setting up a data lake has traditionally been hard to do. Turns out there's a lot of steps involved in setting up a data lake. First, you have to set up your storage. Then, you have to move your data to your storage. Then you have to clean and prepare your data. Then you have to configure and enforce policies on who should have access to the data. Then you have to build tools to make your data available to your users with the right policies. And each of these steps involves a lot of work because it has to be done manually. Customers can spend months building data access and transformation workflows, mapping security and policy settings, and configuring tools and services for data movement. Customers want an easier way to do this, and that's why we built AWS Lake Formation. Lake Formation helps to build secure data lakes. First, you identify existing data stores in S3 or your relational databases. Then, you move your data into the data lake. Then it crawls, catalogs, and prepares your data for analytics. Then, it provides your users secure access through the analytics tools of their choice. Other AWS services and third-party applications can also directly connect to your data lake. Lake Formation manages all of the tasks shown in the middle of this box for you. So it massively reduces the amount of time that's necessary to set up a data lake. So I've talked about the breadth and depth of AWS as the how for customers migrating to the cloud, building new applications with microservices, achieving database freedom, and using the right analytics tools for the right job. Now, I'd like to introduce Sergei Shvetsov, Head of Engineering Cloud Infrastructure at Traveloka. Traveloka started with AWS on day one and has used a broad and deep set of capabilities from AWS as it has grown and expanded its business over the years. Traveloka offers a wide range of travel and lifecycle services that empower people to discover the world. Sergei.
Thank you, Peter, and thank you, AWS, for inviting Traveloka to be part of this keynote. It's a great pleasure to be here. Quick introduction, my name is Sergei Shvetsov. I'm the head of engineering in charge of cloud infrastructure at Traveloka. I've been lucky enough to have a very exciting IT career that started about 20 years ago when I immigrated from Ukraine to Canada. And since then, I have worked in a large variety of roles with many, many different industries and with customers from many countries and continents. Around 2010, in search for more challenges, I relocated to Indonesia, where in 2015, I joined a startup called Traveloka to lead their infrastructure, DevOps, and SRE teams. So in case you haven't heard of Traveloka, we're a technology company with a mission to enrich people's lives by empowering them to discover the world around them. Traveloka provides a very wide range of services that include travel and lifestyle experience in a single platform. Now, allow me to tell you a bit about our history and how AWS has been our partner and allowed us to solve a variety of challenges from day one. Traveloka was founded in early 2012. Our team was just about 8 people at a time, and our mission was to help people move in, out, and within the Indonesia. Our first service was just a flight meta search to help people find local airlines online. At the time, really all we needed is a fast and reliable infrastructure, but something that did not require a lot of upfront investment. And this is where AWS EC2 was just the right service for us. About a year later, in addition to a search, we added booking and payment. So we became not just a search engine, but also a flight booking platform. Around that time, we just added that capability on top of our existing apps. So in order to scale, really all we needed to do is to increase the size of our instances that were hosting our application and databases. A year later, we've added hotel booking, and we've also launched our iOS and Android applications, becoming a full-fledged travel booking platform or online travel agent, OTA. This time, we decided to scale horizontally. While still adding the capabilities to our existing monolithic service, we decided to add more instances to load balance the traffic to our larger group of backend instances. We also started to experiment with S3 and CloudFront by shifting our static content to the AWS Cloud Content Delivery Network. 2015, our app hit 1 million downloads. We've got more international airlines. We've been awarded 2 top brand awards in Indonesia, and our team already has grown to about 600 people. 100 of them were engineers. This was the time our monolithic architecture started to show signs of problems. We had many engineers updating different parts of the same application, deploying it to the same infrastructure at the same time. We started to have a bit of reliability issues because of all that shared infrastructure, shared code base that's been constantly modified. So that was around the time we decided to try a new approach, microservices, which you heard Peter talk about earlier. For that, we needed to scale out and break down our application into many load balancer instances, many application instances, many database instances. We also need to connect all of that together, discover the services. So luckily, AWS had just the right tools for us at the time in the shape of Elastic Load Balancers and Route 53. In case you don't know, it's a very reliable, very inexpensive managed DNS solution. 2016 was a really big year for us. We expanded into 6 largest Southeast Asian markets: Indonesia, Singapore, Thailand, Vietnam, Philippines, Malaysia. Our app reached 10 million downloads. On the back end, however, we were struggling to manage our constantly growing fleet of MongoDBs. So we wanted to explore a managed service. Comes the relational database service and our shifts to Postgres. Around the same time, we started building our data lake and data pipeline on top of Kafka, Redshift, and S3. And we put a lot more focus into security. So we took and made better use of tools like VPC, CloudTrail, Config, IAM, and Amazon Certificate Manager. 2017, more products. We've added Train. We've added flight and hotel packages, local and international data top-ups, attractions and activities. Our app has hit 20 million downloads, and Expedia publicly invested in us, officially making us a unicorn in Indonesia. Meanwhile, we've expanded our tech office to Singapore, and our engineering task force has grown to 300 people. This was a time for us where we decided to focus on speed and reliability. So we once again looked to manage services like Elastic Cache to offload, to reduce the workload on our backend services, Elasticsearch to reduce the latency of our autocomplete and location searches, DynamoDB as an inexpensive, reliable configuration store for our apps, and SQS to further decouple our microservices. In 2018, we've added our first culinary product called Eats and our alternative payment method called Pay Later. We've also, we're very proud to become a media and broadcast sponsor for the 2018 World Cup, FIFA World Cup in Indonesia. And our app has hit 30 million downloads. So at this point, we had a lot more teams, a lot more products, a lot of services and microservices, and we were starting to have issues with the operational overhead we spent on our large self-hosted CI/CD platform. We decided to break it down into smaller parts, lightweight, inexpensive, self-managed pipelines built on top of code build and code pipeline. We also started to reduce our cost by switching towards serverless platforms like ECS, Fargate, Lambda, and API Gateway. 2018, we turned 7 years old, and now we're focusing on improving the product suggestions and recommendations by using tools like ML and AI. As of today, Traveloka's got more than 100 airline partners serving 200,000 routes globally. We have nearly 500,000 accommodation partners in 100 countries. Our app has more than a dozen categories and has been downloaded more than 40 million times. We have about 2,500 people in 7 countries. Nearly 500 of them are engineers. At every stage of our growth, AWS has allowed us to scale our platforms, products, services very rapidly and economically. The AWS tendency to constantly create new features and services, while really hard to keep up with, gave us the tools to continue growing with a lot less effort. And we're not slowing down. This year, we announced our 7th country, Australia, and we opened a new technology office in India. And we keep hiring. So if you would like to be part of our vision, please do visit our career page. Thank you very much.
Thank you, Sergei. It's been great to be with Traveloka every step of the way. Today, there is so much buzz and talk about machine learning. For tens of thousands of customers like Liberty Mutual, C-SPAN, Intuit, Pinterest, Capital One, the American Heart Association, FINRA, AWS is how to do machine learning. However, progress isn't fast enough. Customers want to move faster. And to help customers move even faster, we keep providing more and more capabilities and tools for builders to use machine learning. We've been able to pull from a long heritage of investment in machine learning at Amazon. Whether it's our personalization recommendation engine, or the fulfillment automation and inventory management technology, or voice-driven interactions with Alexa, or our new Amazon Go stores. We've been doing this going back more than 20 years. But if we want if we want machine learning to become pervasive, we need to make machine learning so easy to use for all developers and all data scientists, so it just becomes a common part of your business. In the past year, we've seen more and more customers who are starting to use machine learning in a serious way. And the vast majority of them are doing it on AWS, including Singapore startup vSens, that offers an AI-powered search platform for retail brands, which lets customers, both in stores and online, search for products using images rather than keywords. By using Amazon DynamoDB and machine learning optimized GPU instances, vSens indexes and processes billions of images, handles more than 3 million queries a day, and generates search results for their users in under 200 milliseconds. That speed, recognition accuracy, and scalability has helped vSens grow its business by over 200% in the last year. When we think about machine learning, we think about 3 layers. The bottom layer is where the experts live. It's made up of the frameworks and the interfaces and the infrastructure for the deep machine learning experts. In the middle layer, you have machine learning services that make it easy for any developer or data scientist to build models. And at the top level, you have AI services that loosely imitate human cognition. They enable developers to use plugged-in AI functionality for their applications without needing to get training data or train their own models. Let's look at each of these layers. We'll start at the bottom. If you look at the infrastructure, most deep learning that's being done today in the cloud is using the Amazon P3 instances. Our P3DN network instances provide 100 gigabits of networking. This enables developers to scale their model training performance across multiple instances, which accelerates pre-processing and removes data transfer bottlenecks that slow down their models. The largest instance type, the P3DN24XL, is the largest GPU instance available anywhere. These instances have more than 3 times more networking than any other instance. They have twice as much GPU memory as any other available instance. And they have 100 gigabytes more of system memory than any instance available from any other provider. And now if you look at frameworks, we support a very broad group. More than half of our customers using machine learning on AWS use more than one framework in their day-to-day machine learning work. Lots use MXNet for speech models and recommendations. Others use PyTorch to research new methods. And TensorFlow is often used for computer vision and language models. And if you study history, change is constant. There are going to be new frameworks, and we'll support those as well. The one with the most resonance right now in the community is TensorFlow. So let's look at that one. 85% of TensorFlow workloads running in the cloud run on AWS. Siemens runs their natural language processing model to expedite due diligence on energy projects. Beth Israel, a Harvard medical school, is building a model to accelerate identifying consent from patients and review patient records. And Snap, the maker of Snapchat, built TensorFlow models on AWS to better match ads to users to maximize revenue and engagement. Customers using TensorFlow love the availability of reference code supplied by the vibrant community of developers. But when they start training larger models, they can run into scaling problems. And that's because customers usually need to scale their training across hundreds of GPUs. The inner workings of TensorFlow make this difficult. And scaling across 256 GPUs with standard TensorFlow is only 65% efficient. So we spend time innovating on the way that TensorFlow shares parameters and information across multiple instances to overcome the scaling limitation. This significantly improved the scaling efficiency up to 90% over those same 256 GPUs, allowing customers to train twice as fast on the same GPUs. That's great for training, but what about inference? Running inference in production actually drives the majority of cost in any machine learning workflow. And this just kind of makes sense. You train a model once, maybe twice a week, but in that same time period, you may run thousands or even millions of inferences. Alexa is a great example. We regularly retrain our models to make improvements, but every Alexa request from a customer contributes to the inference. So to help reduce inference costs, we created Elastic Inference and Inferentia. Elastic Inference allows you to use smaller general purpose instances like the M5 and provision just a little bit of GPU for your application. And Inferentia is a high-performance machine learning inference chip developed by AWS. It will provide hundreds of teraflops of inference performance. Multiple Inferentia chips can be used together to drive thousands of teraflops of performance on one server. It will also reduce the cost of inference by as much as 10x, even compared to Elastic Inference, which means huge savings for inference at scale. Elastic Inference is available today, and Inferentia will be available later this year. Now while we're seeing a lot of activity at this lowest level of the stack, the reality is there just aren't that many machine learning experts in the world yet. We're training more of them in universities, but there just aren't that many. So if you want to enable most enterprises and companies to be able to use machine learning, you need to solve the problem of making it accessible to every developer and data scientist. And that's why we built and launched Amazon SageMaker. Amazon SageMaker is a managed ML service in the middle tier that makes it easier for everyday developers and data scientists to get up and running with machine learning. Right now, you can get going with a single click, and you have access to fully managed machine learning notebook environment using the popular Jupyter OS format. SageMaker Ground Truth makes it easy to build highly accurate training data sets and reduce data labeling costs by up to 70% by using machine learning. Next, SageMaker makes it easier to choose and implement your desired algorithm and framework. Our teams have optimized the top algorithms to run more than 10x faster in SageMaker, and you can also bring any algorithm or framework you want. And the AWS Marketplace for machine learning offers more than 150 algorithms that you can deploy directly to Amazon SageMaker. And if you need to teach machine learning models where there is no training data, SageMaker RL allows you to build fully managed reinforcement learning models, including some of the newest and best performing algorithms. It's also much easier to do training with SageMaker than anywhere else. You specify the location of your data and the instance types that you want to use, and SageMaker automatically spins up a cluster to do training. And it spins the cluster down when it's done. Once you've trained a model, you can optimize it further in a number of ways. You can use SageMaker Neo to continually optimize your model for significant performance gains, ensuring you always have the highest performing model for the instances you're running on. And once you've tuned your model, you just pick the instance type, and you can one-click deploy it to production. Once deployed to production, SageMaker manages the compute infrastructure on your behalf. There's no more muck. Today, we have more than 10,000 customers using Amazon SageMaker. Many of those customers are standardizing on AWS for machine learning. Siemens Financial Services uses TensorFlow on Amazon SageMaker to develop a natural language processing model that reduced the time to summarize diligence documents from hours down to 30 seconds. Before using Amazon SageMaker, Siemens Financial Services personnel would need to manually review thousands of pages of documents in order to extract the relevant information. With the help of this model, that time has been reduced significantly. And in ASEAN, Sephora Southeast Asia, a leader in global prestige retail, has deployed Amazon SageMaker in 2 experimental use cases. The first is for sales and inventory forecasting. We're testing different sales forecasting strategies to improve sales tooling in an omni-channel environment. And the second is for product keyword tagging to optimize portions of the product creation process. Sephora is already reducing the time for product creation by 10% on average. Okay, so far we've discussed the bottom and the middle stack of the machine learning stack. First, we talked about the frameworks and the infrastructure used by experts. Then we talked about SageMaker to make machine learning capabilities available to all developers. Now, at the very top of the stack, we serve developers and companies who want to add intelligence to their applications but don't want to build their own models. Customers can easily build these capabilities into their new and existing applications using simple API calls. This increases speed and improves customer satisfaction and insight. We offer a broad range of services, from vision to speech to language to chatbots to forecasting. Let's take a look at a few of them. For vision, we have recognition image and recognition video. This allows you to do things like, tell me what's in this image, or which celebrities are in this image, or is this image appropriate for work? For documents, we have Textract to easily extract text and data from virtually any document. And unlike typical OCR applications, which are not very useful when you have data in a table or data in a graph, Textract uses machine learning to natively understand the document format. So, where OCR simply extracts the text, Textract identifies the position on the page and the relationship between the text. This means for tables, it can extract things like rows and columns. And you can actually take those rows and columns and load them directly into something like your Aurora database. For speech, we have Poly to turn speech to text into speech, and transcribe if you want to transcribe audio back into text. For languages, we offer Translate for translating text to over 20 different languages. Then there's comprehend to understand what's being said, and comprehend medical, which makes it easy to extract relevant medical information from documents and unstructured text. And with Lex, we offer a service that uses automatic speech recognition and natural language processing for building conversational interfaces. We also have Forecast, our accurate time series forecasting service, and Personalize, our real-time personalization and recommendation services. Both Forecast and Personalize are fully managed services, so there's no servers to provision and no machine learning models to build. And both are based on technologies used by Amazon.com. And we've also got some great resources to help you get started across the whole spectrum of machine learning services. We've got Amazon ML Solutions Labs to help you accelerate and use machine learning in your products and processes. It pairs your team with machine learning experts to prepare data and build and train models and put those models into production. We've also got the Amazon Machine Learning University, which expands upon this training and provides learning paths for key stakeholders and specialty certifications. Okay, I promised we'd end with something fun, and you've all been very patient. So I want to talk to you about a new fun way to learn machine learning. AWS Deep Racer is a 1/18th scale race car driven by reinforcement learning and gives you an exciting and fun way to get started with machine learning. Reinforcement learning is an advanced machine learning technique which takes a very different approach to training than other machine learning models. Its superpower is that it learns through rewards very complex behaviors without requiring any labeled training data. And it can make short-term decisions while optimizing for a long-term goal. And what's a race car without a little competition?
Hello everyone, I'm Ryan Marine. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning.
How cool is that? All right, here's how this works. You can build an RL model, either at a workshop right here at the summit or at home. Then you can bring that model to the track and start racing at the AWS Deep Racer Singapore Speedway, set up just outside in the expo hall. And if you don't have a model, you have an option to pick from some standard models in our pre-trained samples at the track. You can do this at any of the Deep Racer League races at select AWS summits throughout 2019. You can participate as many times as you would like. And the winner of each Deep Racer League race and the top 10 point scorers worldwide are going to win a fully expenses-paid trip to Deep Racer League Championship Cup, which will be held at reInvent 2019. So after this session and throughout the day, please go race. Today, you're going to have the opportunity to attend a number of different sessions on services we've discussed today, as well as some we did not. And the one thing I want you to take away is whether you're a new startup, a 100-year-old enterprise, or a highly regulated government agency, you can build on AWS. We have the tools you need. With that, I want to thank you for your time.